Hello, everybody. Welcome to the Open Voice Network webinar on Dialog Events and Interaction Protocols. Very happy that everyone is able to be here today, and I hope you'll find this interesting and informative. So today, I want to mention that this is a webinar presented by the Open Voice Network, which is part of the Linux Foundation, and remind you that the webinar will be recorded and eventually it'll be available on YouTube. You can watch the recording if you like and pass it on to your colleagues. We'll end on time, and the meeting will be conducted in accordance with the antitrust guidelines of the Linux Foundation. I'm Deborah Dahl from Conversational Technologies. I'll be your moderator today, and we have two panelists we'll be hearing from a little bit later: Emmett Coin from EdgeTalk and David Attwater from TalkMap. So just to outline what we're going to be talking about today, this webinar builds on our March 22nd webinar. Some of you may have seen that. If not, there's a link on your screen. We're going to announce our Dialog Events 1.0 specification. We're very excited to have that. And we'll tell you about a few of the features that we're specifying in that document. And then we're going to demonstrate a live demo of some of the features that we're working on for future specifications. Then we'll have a Q&A, and everyone will be able to put their questions in the Zoom chat, and hopefully we'll be able to answer your questions. I'll say a little bit about the Open Voice Network. It's a nonprofit, vendor-neutral community of the Linux Foundation. The website is located at the URL on your screen. I would say it was characterized by two major important initiatives. One is what we call interoperability. That's voice that works like the web. The other initiative has to do with voice worthy of user trust. Today we'll be talking about interoperability, but I do want to mention on the other side of the other initiative, we have a new initiative called Trustmark in that area of work, and it's a program that establishes a set of criteria for trustworthy conversational AI systems. And you can find out more about that on the Open Voice Network website. We can go to the next slide. I did want to say at the outset just a little bit about the role of voice assistants in the world of generative AI language models. We've all seen a huge amount of hype in the press, on the internet, about large language models, which are a type of artificial intelligence that uses deep learning techniques and massive data sets to understand and generate language. I'm sure we've all had experience with these, and we've had questions about how is that related to interoperability of conversational assistants. So what we say is that no one assistant can do it all. These things like ChatGPT or BARD are generic large language models. They only know public information that they can get from the web. They don't know personal information like your net worth, or maybe you're curious about your neighbor's net worth. Well, they don't have that, thankfully. They don't know your personal medical information. They don't know your financial information. They don't know your grades from your classes. And so just in general, they don't know the information that is behind firewalls and paywalls that an assistant from your bank or your university or doctor does know. Everyone is going to be building assistants that use this technology. It's great, it's very powerful, but internally, the assistants will be able to access the sensitive information, but they'll be able to protect it because the assistant will be able to protect it with the proper authorizations. Users will move back and forth between general purpose language models and enterprise models. And so once you have that requirement, they have to be able to interoperate, and that's where we are. So yeah, let's go on. As I said, today's emphasis is going to be on voice that works like the web and how it needs interoperability among conversational assistants. To do that, it's just like web pages interoperate. So what the process is that we're working with is that a conversational assistant is interacting with the user and realizes, however it does that a user's question is outside of its expertise, and then to help the user out by finding another assistant. This is where our standards start coming into play. Identifying another assistant, contacting it, authenticating it, confirming with the other assistant that it's able to address the user's question, and then it sends the user's question and any history to the other assistant, and that enables the other assistant to continue the conversation. Those last two bullets are what we're really going to focus on today. So yeah, let's keep going. So I'm very happy to announce that we've just published the Interoperable Dialog Event Object Specification. We have all of the people who have contributed to that here today. So if you have questions, they'll be able to answer them in the Q&A part of the webinar. Okay, we can keep going. I'll just tell you a little bit about that specification. Here's a quote from the specification. The purpose, what is a dialogue event? It's to define a generic standardized data structure that can be used in any component of a dialogue system or a conversational assistant to express a language event, that is, features associated with a phrase, utterance, or part of an utterance. They take place over a certain period of time, and they are associated with a single speaker. So let's go to the next slide. So our specification is basically represents what one of the conversational participants says or types to the other. And it includes both the user, what the user is saying, and what the system is saying. This interoperable event specification is what lets one assistant pass this kind of information on to another assistant. So it knows what the let's say, for example, what the user said. Dialogue events include linguistic content, which is the speech or text or interpretation of the utterance, and some metadata, like the time span of the event, the confidence, alternative interpretations, and links to related information. And what we have in our publication in 1.0 is a JSON format that's defined formally in a JSON schema that that makes it clear what exactly information is going on. So we can go to the next slide. What you'll see today is in our demo, we'll see what's kind of on the horizon for our next specification. We'll be demonstrating just a simple availability check, how the system can pass on the history of a conversation to the other assistant. And very importantly, we'll be talking about redaction of sensitive information. A user wouldn't like to be just sent around all over the place. We've talked about some use cases in our discussions, and we have an active ongoing activity and defining use cases, but just some quick ideas. User assistant might want to speak to a restaurant's assistant to order a meal. User assistant could talk to an internal organization assistant to help modify the user's information, like changing information on their account. User assistant might use an internal to organization assistant. That might be like a bank to pay a bill. A doctor's assistant might speak to a clinic assistant to get patients' results. And most of those are possibly sensitive information that you want to be kept private. So with that, I'll turn over the discussion to Emmett Coin from EdgeTalk, who will be doing our demo today.
Thank you, Debbie. Next slide, please. As Debbie said, we're going to be demonstrating a few interesting things. We're going to talk about managing sensitive information that you would not want to pass around to other assistants. We're going to talk about the inquiry of availability, essentially what we're calling negotiation. Can another assistant do what we need before we pass on to it? And making conversations that span multiple assistants more efficient. So why don't we go right into that, and I can share my screen. And where is it? It is here. Share. Make that bigger. Okay. All right. So what we're going to do here is play around with if you've seen the previous demo, a playground that we created to test interoperability. And I'm going to go through a few things, a little bit of a repeat of the previous demo in the previous webinar, which I would recommend you go and see. It might provide an even stronger basis for what we're doing here. The first thing we're going to do, if you recall from the other demo, was I talked to an agent about a specific task. And why don't we just dive in, see how that works?
Cassandra here. Welcome to the multi-agent demo.
What do you know about martinis?
I don't have that expertise, but...
You're not so secret agent. Bond here.
What do you know about martinis?
A marvelous drink. What do you want to know?
Should they be stirred or shaken?
Always shaken, never stirred. And absolutely never any ice.
Thanks. Let's go back to Cassandra now.
It was nice while it lasted. It was fun talking to you. Bye for now.
Hello again. I was just wondering, did you get what you needed?
So what we saw was a simple delegation, what we call a delegation to another assistant. And what happened was, if you noticed, I'll show you more detail later, but we went in cold and Bond didn't seem to know what we wanted to know. And I had to ask the question again. So what if we added some history to that and it knew what I had asked Cassandra before? So let's try that. I want to buy an Aston Martin.
I'm not a high-end sports car person, but I know someone who probably is.
Allow me to give this a go. Terrific automobile. If you get one, it absolutely needs an ejection seat.
Thanks. Let's go back to Cassandra.
It was nice while it lasted. It was fun to talk with you. Bye for now.
Hello again. I was just wondering, did you get what you needed?
Cassandra, show me the sequence diagram.
Here you go.
Now, if you remember from the previous demo, we have this idea of a sequence of events, and each vertical column is one of the players in this. There's me, the red-blooded human. There's the gray neutral assistant browser. In this architecture, the assistant browser is like a switchboard that contains the technologies for text-to-speech and for speech recognition. There's Cassandra, who I started with, my primary agent, my initial agent, and we eventually talked to Bond. So here's what happened. Cassandra was there and I asked her something about martinis. The assistant browser recognized that and sent an ASR event in OVON format to Cassandra. Her natural language system, dialogue system, figured out what to do with it. And she came back with an event, a TTS event, and a connection request because she knew she couldn't handle that. We don't need to get into how she knows that right now. We're working on that, but she knew that she couldn't handle it. So she said, I don't have that expertise, but. And then she connected with Bond. We'll talk about this negotiation later, but this is how we negotiate with Bond. And then he sends back a response, basically a cold open. Bond here. And then I have to ask the question again. What do you know about martinis? And we go back and forth. It's a great drink, stirred and shaken, not stirred, all that. Then we go back to Cassandra. And Bond has to understand, okay, we're going back to the agent that we came from, and sends a message back to the browser, the assistant browser, and says, let's say this and reconnect with Cassandra. So nice while it lasted. Bye. A negotiation. Cassandra comes back. Hi, how'd it go? This time I said I want to buy an Aston Martin, but this time we're going to do something different. Cassandra recognizes she can't do that either. She negotiates with Bond, who probably could. And Bond, in the actual connection event, instead of a delegation, we did a handoff. Now, that's just a working term, but it's essentially a delegation with history. And now Bond knows the question that was asked. So immediately Bond can say, allow me to give this a go. And this is, silly stuff, ejection seats. So that saved a step. That made the conversation more efficient. It is annoying. It addresses an annoying problem we often have with multiple agents assistants when we deal with them. It's because you have to repeat things so often. History will be important to deal with that. So let's go back to here. So that was a demonstration of history and how useful that could be. And just think how useful it would be, not just for the silly thing, but for addresses, for dates. Maybe you were talking about shoe sizes and you go back to your store again, and it should just remember or be able to look through the history and say, I know what you were ordering. So that's good. Now let's take a look at the second example, which is how to deal with sensitive information. We're calling this redaction. So those who saw the first demo, remember I went to my pharmacy. I need to pick up my prescription.
I will get your registered pharmacy agent.
Ventura's Pharmacy. Hi, my name is George.
Now, in the original demo, we went in and we just asked about our medicines, and it just confirmed we had something to pick up, and that was it. But this time we're going to add some sensitive information. What is in the prescription? I need to pick up my medicine.
Yes, Emmett, I see we have your authentication token here. Your amoxicillin, 500 milligrams, 30 capsule prescription is ready to pick up.
So it spoke what I was supposed to, what was in the prescription, but it put a redacted medication in. Part of the reason we're trying to redact it, other than just blacking it out, is to give some sense for the history. If something were to look, another assistant were to look back at this, it would understand we're talking about medications here, but doesn't know which ones particularly. This is also a matter of policy. It's been brought up that maybe some requirements are that you can't speak this medication, but you could display it. And that would be an option at the assistant browser site, whether to display it or speak it. Thanks. Let's go back to Cassandra.
No doubt. Thank you for your business and have a nice day.
Hello again. I was just wondering, did you get what you needed?
Show me the sequence diagram.
Here you go.
So this time you can see that we have added George, the pharmacy agent, to this. And we negotiated with him. We got a delegation. And then we see that I need to pick up my medicine. The agent understands what that means with its own business rules. It says, yes, some sort of a token was passed along. It knows me, and it can tell me, yes, my amoxicillin, whatever, is ready to pick up. And then we can go back to Cassandra. Now let's take a look at what we're calling history, which is a representation of the OVAN messages as they went through. Let's go down to the bottom here. These are JSON messages, and while they're not exactly, these are working playground prototypes that are coalescing and formulating themselves along with our standard as we evolve the standard. So don't take this as gospel, but this is very close. So we had an input event where, no, that's showing the sequence diagram. Let's go back to George. Where are we? Hi, my name is George. You can see these things. I won't go too fast. The agent, the pharmacy says, hi, my name is George. It's packed up inside some JSON. We do a recognition. I said, and the recognition was turned into text, I need to pick up my medicine. George said, I see that we have your authentication token here, your medication. This is what will go into the log. The unredacted say was what had the actual medicine in it, but it was immediately deleted. It's like it just vaporized, and so it's not part of the record anymore. So that's one way we're thinking of protecting sensitive information. So I think that's pretty much all we need to know. Again, the separate policies could be established here for however you want to deal with that. Let's go, let's now take a look at the negotiation parts of this. We talked a little bit about how we have to deal with, interesting. Underneath my control for the Zoom is the tab I want to get to. So sorry. Okay, if we want to go down here, let's take a look at some of these negotiations. Some of the time you're going to need to negotiate with an assistant and say, is this, are you capable of handling this? Do you know about martinis? Do you know about my prescription? And right now we're just testing a pathway to send a negotiation. Are you available? That's a pretty dumb question, but it comes back yes. But later we would expect to have other questions that might be important, like, do I trust you? Do you trust me? Here are some credentials. With the pharmacy knew it was me, so probably credentials would be sent along in a negotiation package. So I think this is pretty much, well, there's one other thing I would like to bring up, is that this playground architecture basically has all the agents, the assistants are just text bots. If you think about it, everything is going through as text here. If we look at the history log, there's just text to say, and there's just text that was recognized what I said. So basically, any sort of text-based bot would be easily implemented in this methodology. There's nothing really fancy about the OVAN standard that wouldn't make it simple for someone to use it with a simple exchange of input and output text. We're also working on, but there are no promise dates for, some sort of a hello world server to help people play with this, that they might be able to insert their own small test assistant and work with other people. Now, that's something that we can't promise because we're going to need some help with that. And certainly, by all means, contact us. Debbie is going to talk about how to do that a little later in the talk. So please get your pencils out, contact us, please. So I think that just about does it for me. Let me hand this back to, I think Jim is going to take over here.
Thank you, Emmett Coin. I'm Jim Larson. My job is to ask the panelists questions, especially the questions that you enter into the chat webinar and chat space. So if you have questions, please enter them now. Debbie Dahl, you started the webinar with a great explanation of LLMs and generative AI. Everybody is concerned that's going to take over the world. Conversational agents based on generative AI will be the ultimate end all for everything. We won't need anything else. Why do we need interoperability if interoperative chatbots are going to take over the world? Why do we need interoperability? Debbie?
Thank you, Jim. That's a great question. I think the essence of the answer to that is we're still going to have thousands, millions of AI assistants, and for the most part, they'll probably evolve toward using large language models as a tool in their systems. But if you need to have knowledge from more than one enterprise, then you'll need to switch between the assistants, one for your bank, your doctor, your pharmacy, or general assistants with specialized knowledge like that know about drinks and cars. As soon as you need to do that switching among assistants, then there'll be a need for assistants to interoperate. So we could say that generative systems will assimilate and make use of the collaborative patterns that we've defined at the Open Voice Network, the delegation, which you saw here, plus our other patterns that we'll be detailing in the future, channeling and mediation. So I think there's a big role in the future for interoperability. It doesn't go away because of large language models.
Thank you, Debbie. A question from Phil Shen, targeted towards Emmett. Phil asks, how does one bot connect to another? You demonstrated how Cassandra could connect to the bond agent, and it happened almost magically. How would that happen? Do we need a registry? Emmett Coin, please.
Very good questions, Phil. The demonstration that we were doing here was purely HTTP. The assistants were just behind a simple server. Instead of sending HTML and getting HTML back, we sent OVON and got OVON back. So the assistant browser took the OVON packet, opened it, and then spoke what it needed to, and the assistant browser did a recognition and packaged it up in OVON and sent it back, just like a web page. That's exactly. Now, the question of a registry, yes, clearly we're going to need some way to do what our group is calling discovery. How do you find these other agents? And we have lots of ideas about that, but we would welcome more. So please join.
Thank you, Emmett. Another question for you, Emmett. This one comes from Ashok. To protect individual identities, how are we authenticating a voice? How do we know that the person who's speaking really is who he claims to be? Do we use voice biometrics? What should be used? How is that handled, Emmett?
Well, in this demo, it's not handled at all. We're simply working on the functionality of inter-assistant communications, but that's a good question. And I think that would be put on, that would be something that we might standardize. We might have a standard biometric and send some sort of token. That is not currently what we're working on. So it's important, but not addressed today.
I'd like to add to that, John Stein has just published a document about requirements for this kind of thing, but we need more experts to help us with that. A general question, this one will be targeted towards David. You were one of the authors for this new document that we've published the dialogue engine, the event specification language. What do you use that language for? Why is it such a big deal, David?
Thank you, Jim. Firstly, just to be clear, it's not a standalone specification. So it's a definition of an object format that could be reused in all manner of interfaces that you might use for reusability. So the specification is saying, here's a way of wrapping up a language event in a way that will be understood in a common way between different components, and then being able to add layers in. So for example, text or pronunciation or interpretations in such a way that various components in language systems can use these events, they can be passed between them, and they can also then be used in the higher level over messages. For example, the negotiation message that Emmett referenced. So the negotiation message will say, you know, for example, are you available and are you able to handle this? And then this would be a dialogue event utterance from a user, for example, or it could even be a contrived utterance asking if it could achieve it. So it's a foundational specification that we think is going to be generally useful across the industry, not just in dialogue systems. So for example, when Emmett showed the dialogue history, we're anticipating that dialogue history, which is really, really important for large language model systems in particular, will just be represented as a sequence of dialogue events. So if you imagine just you've got a sequence of he says, I say, he says, I say, they're just dialogue events. Package those up together, you've got yourself some conversational history. So this is a foundational spec. We want to use it now to build out on top of it to start building these higher level ones.
Cool, David. It's nice to build a specification that can be used for your specific purpose, but can also be used for other things.
Yeah, that's our hope. Yeah.
A general question about history. This will be targeted towards Emmett. You demonstrated how the Cassandra robot could ask a question. We asked a question to the Cassandra robot. It was not able to answer it. So it connected to the James Bond robot for the answer. And the James Bond robot was able to understand what the request was without the user having to repeat it. I thought it was almost like magic. How did James Bond know what was going to be asked before he joined the conversation? Explain the concept of history. What else can history be used for besides avoiding repeating the question that the user asked when he transferred to another agent? How else can it be used?
That's a very rich and deep, good question. The first one about the bond one is easy. Like David was talking about, there's a history, which is just a sequence of all the he said, she says that go across. And when we connected with Bond for the Aston Martin question, we simply passed along the history, which Bond just simple-mindedly looked at the last question and said, it was given to me, maybe that's what I can answer, and and Bond could answer it. So it wasn't magic, it was just the history of the question that Cassandra knew she couldn't answer and passed it to Bond. He gave a go at it. The richer question, which was, refresh my memory, Jim, what was the last part of that?
What else can we use this capability for?
Very good. What else we can use it for? Imagine you're talking to your pharmacy like we did with George, the pharmacist, and we're talking about the amoxicillin that's ready to be picked up, and then I maybe do something else, but then I go to my doctor's bot, a clinic bot, and I ask a question about something of my condition, and the bot can now look through the history and it can see, oh, you've inquired about picking up your medication. That's not in the history of what it was, but the doctor bot knows what that was. And it says, did you pick up your amoxicillin yet? Start using it now. That would be a very good use case for how you would save a lot of steps in conversations by knowing things like that happened earlier in the conversation.
If I could jump in and mention a couple of other potential uses. One is that, particularly with large language models, providing continuity in dialogue involves an understanding not of what was just said, but potentially conversation steps reaching back 2 or 3 steps back. That would allow an agent to, for example, do things like language reflection, where it chooses to use the same words that the user is using to talk about certain issues, which is something that we do as human beings. It will allow things like elision, so you could and anaphora, so we can refer back to this and that. You know, we can say, oh yeah, I can do that for you because we know that that has just been mentioned, whatever that would be. And also, interestingly, it opens up the possibility that if you're a large enterprise, you're not just going to have a single bot. You're probably going to want to chop your functionality up into individual bots. And there's no reason why those individual bots can't use the OVON standards to essentially pass control between each other. So you may, for example, in your enterprise, have a bot that understands how to move money around. You may have another one that understands how to authenticate people. It may not actually change its personality. Essentially, you may be going to sub bits of its brain. And that was another use of Dialog history, is for bots essentially to be able to use the OVON standards as internal ways of passing control between various modules and maintaining continuity.
Thank you, David. One of the things that annoys me the most when I use automated agents is that I go from segment to segment, the agent asks me the same question again and again. Please enter user ID. Please enter your birth date. I have to seem to enter that multiple times during a conversation as we switch from agent to agent. How can this be avoided with your system, Emmett? How can history be used to avoid that?
Well, I think, as David said, and we've all discussed, that if you look back through the history and you've mentioned what your address is, it probably would be easy to identify what an address is, or maybe we come up with a nomenclature for tagging an address. That's a future sort of thing we might think about, but the address is there. And why not just pull it out of the history and use it? That just makes perfect sense. People would do that all the time. You might have if it was 3 conversations back, you might have the agent say, is that your address in Belleville? Is that the right one? It might say that, but it really makes the conversation more natural. And I expect people will like that.
We're anticipating that there's really a distinction between what we call dialogue history, which would be a unformatted record of the conversation as it has evolved, and also context, which potentially would be structured information, just as web pages would pass structured information between them. We're envisaging a combination of the two. The beauty of language systems is they don't need to know the structure of things in order to be able to deal with them, because the whole beauty of language is that you can just, you know, pull information out of it, which is what we do. So we're seeing both will probably emerge as we move forwards.
I think we're getting close to the end of our time. And so I wanted to suggest that maybe we have time for one more question. I think there was one more question in the chat.
A great question from Alan
yes,
Wiley in the Q&A. If we could, regarding protecting user data in stored conversational history.
Searching for that question.
How do we protect user data in stored conversational history? Who gives permission to use the data, and can a user get a history of who has used their data?
If I could hazard an answer to this, we don't have a clear answer. It's a really good question, and we're very well aware of the issues. The issues of anonymization is one way to address that problem, but it's probably only a simple layer. One of the other things we have discussed but have not explored deeply is, for example, having the conversation history being owned by a third party, so that essentially you need permission to be able to access it. Imagine a server that stores your conversation history, and then you can grant permission for people to access it. That will be another way of looking at it at various different levels. But we wouldn't claim to have got all the answers to this bit yet.
Right, but one short thing I might insert here is that in this concept of redaction that I demonstrated with the pharmacy bot was in charge of what it redacted. So each assistant can redact things and say that they're private. That's the initial hiding thing, but they may also provide some sort of access code, as David said, that would go into a bigger repository and says, oh, maybe this isn't revealed to everyone, but to certain classes of people. So that's all in the future.
The final question comes from,
Oh.
again, Phyllis Shen.
Jim,
there
I'm
cultivate-
I'm sorry, we don't
cultivational
have time
playlist?
for any more questions. We're just going to wrap up. Sorry, we only have a few more minutes left.
Go ahead, Debbie.
So I just wanted to give you a couple of more pieces of information about how we can get some participation, hopefully from some of you. We have two kinds of interesting areas where we could use some help. You can volunteer to help work on our use cases and our specifications. And Emmett mentioned help with the implementing the bare bones skeletal assistant, open source assistant that people can play with. And we're also very interested in having people who want to try to implement the specifications on their own use cases within their own enterprises. And we have a URL on the screen. This is where we have a list of volunteer opportunities in addition to the ones that I mentioned. There's lots of interesting things you can do to help us. So please take a look at that URL and get back to us. And the last thing I wanted to mention was following up on this webinar. We'll have a recording. It'll be available on the OVON website. It should be available fairly soon. So if anybody has colleagues who didn't get a chance to come, they can certainly take a look at the recording. You can also take a look at the specification, the Dialog Event Specification. We'd love to have your thoughts. And we have a mailing list on groups.io with the URL on the screen where you can send any comments or ask any questions about the specification. Other questions, we have another email address on the Open Voice Network website, and we have a form if you wanted to contact us with just general questions. So with that, I'd like to thank everyone for your attention. And I really appreciate the questions. Are really, really interesting and thoughtful questions that we'll try to follow up with. Thank you.